Example 3 for substitution. As I inspect the two equations, I notice that the second equation already has the y isolated. As such, it tells me that I can go to the first equation, and everywhere I see y, I can replace it with this rule. And so I'm going to write an equation that says 2x minus 3. Notice that that coefficient didn't go anywhere. All I'm doing is replacing the y. And so that's why I like to use the bracket here and put the rule inside of it. 2/3 x plus 4 equal 5. I've effectively created an equation that just has one variable in it, and now I want to solve that. You may notice that there's a fraction there. That fraction should not concern us, because if we distribute, these 3's are going to take care of themselves and the fraction will drop out. Now as I solve this, I'll get 2x negative 3 times 2/3. Negative 3 divided by 3 is negative 1. Negative 1 times 2 is negative 2x minus 12, because negative 3 times 4 is negative 12, equals 5. KISS, keep it simple, silly. Combine your like terms. You get 2x take away 2x. 2x take away 2x. That variable is going to drop out. That drops out, that's 0. And so I get this statement of negative 12 equals 5. I evaluate that statement. That statement is clearly false. And what do you do when you get a false statement? Your variables drop out, false statement. You answer empty set. In the context of solving systems of equations, what an empty set means is that those lines are parallel. And I kind of knew that from the get-go. If you look at the slope here, it's a over b, change the sign, the slope was 2/3. Obviously from the second equation, the slope, because it's in slope-intercept form, was 2/3. There's only one thing that could happen. One of two things. It's either that you have parallel lines or the lines coincide. Because these start at different y-axes, points of intersection, it's guaranteed that they're going to be parallel. As I work this out using this substitution method, I got the empty set. The only answer I would want to see is parallel. You have parallel lines. This is example 3. We isolated a variable, we solved, the x variable dropped out, was left with a false statement. False statements mean parallel. If the variable would have dropped out and we would have had a true statement, like negative 12 equaling negative 12, we would say that they were lines that coincide. There were an infinite number of solutions. Example number 3.